Hello students, I am Bishwanath. Welcome to my YouTube channel Best Physics Guide by Bishwanath. Today I am going to discuss about a very interesting topic. It is the wave-particle duality of matter, de Broglie's hypothesis and dual nature of light. In my previous video, I already discussed about the particle nature of light. That is, light can show the particle nature in case of photoelectric effect, in case of quantum effect, in case of photosynthesis, etc. Again, light also responds in diffraction, interference, polarization, etc. We already discussed about these topics in my previous videos. Okay. Now you have a question. Then what is the exact nature of the light? Is it light a particle or is light a wave? There is some confusion. What is the exact nature of light? Which one is correct? Particle nature or wave nature? So today I am going to discuss about the dual nature of light. Okay. De Broglie discussed de Broglie about the dual nature of light, or de Broglie state a hypothesis about the dual nature of light or wave particle duality of matter. He told that a very tiny particle having some velocity can show the wavy nature. That is, a very tiny particle having moves with some velocity can exhibit wavy nature. And on the other hand, the wave can show the particle nature. We already observed that in photoelectric effect, the light, although it is an electromagnetic wave, it shows particle nature. Also, light exhibits Compton effect, which supports the particle nature of light. But Maxwell already proved that light is an electromagnetic wave. That is, an electromagnetic wave can exhibit particle nature. On the other hand, some particles can exhibit wavy natures. For an example, the electrons are very teeny particles, move around the nucleus in an atom. The electrons move in a orbital. Okay. In the orbital, the electrons shows the wavy nature, and the wavy nature of electrons supports the de Broglie hypothesis. That is, the Bohr's model supports the de Broglie hypothesis, and we can also prove Bohr's theory about electronic model or electronic configuration by de Broglie's hypothesis. That is, the teeny particles can exhibit wavy nature. That is, a light or a matter have dual nature. When its mass is very small, then it is a dual nature. That is, a matter can exhibit wavy nature. Vice versa, a wave can exhibit particle nature. That's why we can say that light has a dual nature. Okay. Therefore, we can say the photoelectric effect, Compton effect, these are true. On the other hand, the polarization, diffraction and interference and Maxwell's formula about light wave also true. Okay. Now I am going to discuss about the Broglie's hypothesis. Let lambda be the wavelength of the matter wave and p be the linear momentum of the particle. Then according to Broglie's hypothesis, we can write p lambda is equal to h, where h is the Planck constant. That is, the here p is the linear momentum of the particle, which shows the particle nature of the particle, and lambda is the wavelength of the matter wave. Therefore, lambda shows the wavy nature of that particle, and you can see that p is inversely proportional to lambda. That is, the particle nature and the wavy nature are inversely proportional to each other. That is, when the particle shows the particle nature, then its wavy nature is suppressed, and when the wavy nature is dominated, then the particle nature is suppressed. That's why de Broglie gave this hypothesis p lambda is equal to h. This is a very small formula, but it has huge importance, and from this hypothesis we can remove the confusion between the wavy nature and particle nature of light, and from this formula we can explain about the dual nature of light. That is, a light has dual nature. It has particle nature in Compton effect, photoelectric effect, photosynthesis, and it has the wavy nature in case of polarization, diffraction, interference, etc. This is a vacuum tube. Inside this vacuum glass tube, these are two plates, metal plates, which are connected by a very powerful battery having high potential difference V. Capital V is the high potential difference between the two plates. An electron moves from the negative plate to positive plate with velocity small v, and small m is the mass of that electron. Therefore, according to the principle of conservation of energy, we can write that the kinetic energy of the electron is equal to the potential energy of that electron. That is, half m small v square is equal to small e into capital V. And you know that p is equal to mv is the linear momentum of that particle. Therefore, p is equal to root over of 2mev. This is the expression of the linear momentum of that electron in terms of potential difference between the two electrons. From this formula, we can find out the wavelength of the electron, that is wavelength of the matter wave. Therefore, the wavelength of the electron lambda is equal to h by p. This lambda is equal to h by root over of 2 mev, capital V. Now putting the values of small m and charge of, that is the mass of the electron, and charge of an electron, that is value of small e, we have lambda is equal to 12.27 by root over of capital V angstrom. That is, the wavelength of the matter wave is inversely proportional to the square root of the potential difference. Devision Germer proved experimentally about the Broglie's hypothesis. That is, Devision Germer experiment proved Broglie's hypothesis. This is a filament which emits electron, and A is the anode which accelerates electron. These electron beams strikes the target S. It is made by nickel crystal, and after diffraction it moves toward the dictator, and this dictator connected with a galvanometer. By this galvanometer we can measure the energy of the diffracted electron beams. This dictator dictates the electron beams or electrons which has the same energy as the incident electrons. That is, the incident electrons and the diffracted electrons which has the same energy which is dictated by the dictator. By this dictator we can dictate the energy of the incident electrons, and this dictator can rotates with respect to the crystal. That is, theta is the angle between the incident electron beam and diffracted electron beams, and theta can be changed by the changing the position of the dictator. Okay, now we can plot the intensity of the diffracted electron beams with the angle theta, and we can find the following graphs. From these graphs we can observe that intensity of diffracted electrons or incident beams, intensity of incident beam is maximum for 54 volt and at 50-degree angle. Okay, that is, at 50-degree angle and 54-degree potential difference, the diffraction pattern gives the bright fringe. That is, this is the constructive bright fringe is formed at an angle 50-degree for 54 volt. From this principle, from this phenomena, from this observational value, we can find out the wavelength of the electron, incident electron, using formula. Now let n is the order of diffraction fringe. Phi is the angle of diffraction, is equal to 90 degree minus here 50 by 2 is equal to 65 degree. D is the distance between the two crystal layers. Now from Bragg's formula we can write 2d sin phi is equal to n lambda. For n is equal to 1, we have lambda is equal to 2d sin phi. For nickel crystal, D is equal to 0.91 angstrom. Therefore, from experiment given by Devision and Germer, we can find out the lambda of the electron. Lambda is equal to 2 into 0.1 into sine 65 degree. This is equal to 1.65 angstrom. Now, from the hypothesis of de Broglie, the wavelength of the moving electron is lambda is equal to 12.27 root over of capital V angstrom. This is equal to 12.27 by root over of 54 angstrom. This gives lambda is equal to 1.65 angstrom. Therefore, the two values, which is experimental value and which is theoretical value, supports each other. Therefore, the Devision Germer experiment supports de Broglie's hypothesis. That's why de Broglie's hypothesis is true. Now, we are going to discuss about the proof of de Broglie's proof of Bohr's model, Bohr's atomic model from de Broglie's hypothesis. According to de Broglie, if r be the radius of an orbital electron, then it follows the relation 2 pi r is equal to n into lambda. That is, an electron moves around the nucleus must have the wavelength which is integral multiple of the integral positive multiple of its wavelength, that is n into lambda. That is, the wavelength of the orbital electron cannot be fractional. Therefore, 2 pi r is equal to n into lambda. Here n is equal to 1, 2, 3, that is any integral positive integral value. Here lambda is the wavelength of the matter wave. Now we know that lambda is equal to h by mv, where mv is the linear momentum of the orbital electron. Therefore, 2 pi r is equal to nh by mv, or mvr is equal to nh by 2 pi. You know that mvr is the linear, is the L is equal to mvr is equal to L is equal to angular momentum of an orbital electron. And you know that h bar is equal to h by 2 pi. Therefore, L is equal to, we can write that n into h bar. Okay. This is the Bohr's atomic model. Therefore, we can easily prove Bohr's atomic model by de Broglie's hypothesis. Now, I am going to discuss about the concept of group velocity. From de Broglie's hypothesis, we can write that lambda is equal to h by mv. Here m is the mass of the particle and v is the velocity of that particle. And again, we know that E is equal to h into lambda nu, h into nu, where nu is the frequency of the radiation or frequency of the wave. E is the energy of the photon particle. E is the energy of the photon particle. Therefore, we can write that nu is equal to E by h. And from Einstein's relative special relativity, we know that E is equal to m into c square. Therefore, nu is equal to mc square by h. If u be the de Broglie's wave velocity, then we can write that u is equal to mu into lambda. Therefore, u is equal to c by v square. Okay. And now we can say that since c is greater than, when c is greater than v, then u is greater than c. But from Einstein's special theory of relativity, we can say that no particle can move greater than the velocity of light in vacuum, that no particle have the velocity greater than c. But from this equation, we can see that u may be greater than c. It is impossible. Then Schrödinger suggested that the particles, the particles may move as a group. That is, the waves can be moved as a group, and u is the phase velocity and v is the group velocity. Okay, that is with the movement of a particle, some waves is associated. That is, the wave can form a group and they are known as wave group, and these waves or group of wave moves along the particle with the velocity v. That is, v is known as group velocity, and the wave moves along the velocity u. This is known as phase velocity. This is the relation between group velocity and phase velocity according to Broglie's hypothesis. Now the characteristics of wave, matter wave. Now the characteristics of matter wave. First, matter wave is not a electromagnetic wave. Okay. And second, wavelength of matter wave is inversely proportional to the square root of potential difference. That is, lambda is inversely proportional to 1 by root v. Third, in vacuum, the velocity of matter wave depends on the wavelength of the matter. I'm going to complete my video. I hope you understand today's topic. Thank you for watching my video, and please subscribe my channel and click the like button. Have a nice day.